So blockchain technology is becoming incredibly popular these days.
Why? Very good evening, everyone. My name is Mohit, and
I'm the blockchain leader at GDSC VIT Bhopal, and I welcome you all to this wonderful session of Introduction to Blockchain Technology. So let's get started. Before starting, I would like to make a quick announcement. The BlogCon for WinterFest 2022 is live, and those of you guys are interested in writing blogs or in any content, you guys definitely should participate in this contest. The deadlines are 30th of December, and if you guys want to learn more about this, you can check our social handles. So about the speakers of today's session, my name is Mohit, and I'm the blockchain lead at GDSC. And
us, who's the GDSC VIT Bhopal.
So what will you learn in today's session? Before the session ends, you guys will be really clear about what the blockchain technology is and how it works. We'll be looking at how the governance and regulation is maintained in the blockchain technology. Uh, then we'll be then we'll be looking at the use cases of the blockchain technology. There are many applications of blockchain technology, and we'll be looking at all of them one by one. Then comes the concept of smart contracts. Smart contracts are really fun, and it is one of my favorite topics. So we'll be covering that too. Cryptocurrencies. Cryptocurrencies is, I think you've all heard about, and we'll be looking at cryptocurrencies in our session too. Then we'll be looking at the future of blockchain. Is there any real future in the blockchain technology, or how's the condition? So we'll be covering that topic too. Then at the finally, we'll be looking at how you can become a blockchain developer, and all the roadmaps will be provided. So let's just get started. So here comes our first very basic questions. What is blockchain? So before directly addressing to the topic, what exactly is a blockchain, let us try to take example, real life example, and how blockchain really solves that issue. Consider a real life transaction, digital transaction that is happening in our today's real world. Imagine I send 100 rupees to say Piyush. So this is what exactly happens in the back end. Whenever I press that send button, so this is what is happening in the back end. So whenever I press the send button, the send request goes, and then it reaches to another bank server, which may be of different. Suppose I have a bank account in SBI, and the person who I'm sending might have a might have an account in Kotak or other banks as well. So the server gets the request to another server, and then the transaction is completed. So as you can see, the whole cycle is being uh, happening in this transaction. So what the drawbacks of these transactions are, these transactions can be hacked, of course. Like it is really difficult, but these transactions can be hacked, and these are not secured. And a lot of times what happens is there is the servers might be down due to maintenance issues. I have personally faced this problem a lot of times, personally with SBI. I'm sure you guys must have too. So there are a lot of issues with the conventional server methods. The maintenance issues, the security might be get hacked. So
You said the transaction is
real currency being there is no real currency being transacted to second person's account. It is just a ledger. Your bank account just maintains a universal ledger of how much money do you have and how you are spending. Suppose I have 100 rupees, and I send 10 rupees to someone. The bank just do is it just deducts, it just does minus 10 in my bank account. Nothing else. There is no real currency being transferred from any bank account. And if I get 50 more rupees, it is just add 50 rupees to my account. It is just maintaining a ledger. That is what it is called. It is just maintaining a ledger. So considering all the problems that we might face in this real world scenarios, imagine if I could tell you there exists a technology on which you could maintain all these transactions
Transactions
on a
ledger.
there's
No
no
server
server
involved,
but
just
just one universal ledger, and that is highly secured. You cannot even tamper with it. Even the CEO of the bank cannot tamper with it. It is highly secured, highly encrypted, and that would be such an amazing thing, right? You don't have to wait for servers, or there might be not any hack attacks, or it is just transactions on a universal ledger. So that is
technology is.
so.
So let
Let's
us try
try
to
to
understand
understand with
the
a
definition.
definition. So blockchain is a decentralized, distributed, and public ledger that is used to record transactions. That's all. It is used for recording transactions across many computers in forms of blocks. So these all transactions are happening in forms of blocks. So uh, let us try to understand our definition of a single block. What these blocks are made up of, and how the block works exactly. So a block
Three main other components as well,
but
but
it
comprises
comprises
of
of these three main fundamental components. So the first one is your data. Of course, you're going to need a data field. How you're going to send your transactions? You need a data field where you can send some sort of data. It might be a transaction, or it might be whatever other field of data. There are numerous ways of data types we have. We have images and whatnot. Then we have hash. Hash is a really good thing, like sort of
digital fingerprint, unique
data.
So
So
imagine
imagine having any sort of data, and that data is encrypted with an hash algorithm. We'll be discussing that hash algorithm. What is it? But it is totally different every single time the hash is created for a data. It is totally different, and you cannot tamper with the hash. If you try to change it, it is not even decryptable. You cannot even decrypt the hash. So it is that sort of highly encrypted fingerprint, you can say, of any data, digital data. Then comes hash of previous block. Otherwise, how would you really connect a chain? So this is how we connect a chain of all the blocks. Uh,
the hash of previous block and succeeding
with
the next block.
and it continues. So what happens is, when you connect those all the hashes with within those blocks, it creates a chain. So there comes block chain. The definition defines itself. It is chain of all those blocks, and all these blocks are connected with an highly encrypted hash algorithms. I've talked about that hash algorithms a lot of times. So let us try to have a visual demonstration of what that hash algorithm really looks like. So I have a demonstration. So
Data field, hash algorithm that I talked about,
it is
called
called
SH.
SHA-256 algorithm, SHA-256. So SHA-256 has a 256 bits of 64 character unique code. Every single time I whatever the data, whatever the encrypted hash we gets, it is going to be always going to be 64 character long. It is not suppose it is not going to be like happen like sometimes we have 15 or 20. No, it is going to be 64 character long every single time. So I wanted to
On the screen right now.
the moment I type anything, suppose I type hi, as you can see, the hash has been totally changed. The hash is 64 character long, and you cannot even try to decrypt the data. The algorithm is highly decryptable. So imagine, you guys must be wondering, what if I just type H, it must be close to what HI really is. So that is not how hash algorithm really works.
every single piece of data.
Even
Even if
for
I write
H, as you can see, the hash is totally different from HI. So it gives a totally unique hash every single time. So uh, let us try to extend this idea of hash with a block. So what happens in a block is, as we talked earlier, a block contains data, and that data has a unique hash. And we'll talk about nonce, what nonce really is. And we have our block number. So block number is just the indexing of the block for uh, which block we are on right now. So imagine, so what we'll talk about the nonce. So
nonce
nonce
is
is
like
guessing
guessing
the
hash.
hash. So what is the probability of hash starting with four different zeros? As you can see, the hash started with four different zeros. So if I type HI, as you can see, the big block has turned red because the hash is not starting with four zeros. So now what is the probability that it started with zeros? So there is, so that is where the none concept of nonce comes in. So I can just type all day long, try to figure out what is the correct number. Suppose I type 1, the hash is different. No, it doesn't start with 0. 2, no, it doesn't start with 0. We can just
Five,
6,
six,
7.
7.
Yeah,
Yeah.
7 starts with 40. So you can just try all day long trying to figure out what is the probability of a hash algorithm for that digital data starting with four zeros. So that is what the nonce concept comes in. So this is what a block looks like in general. So what exactly is a blockchain? Exactly, you guys guessed it right. These all blocks are connected in chain, and how they are connected? They're connected in with their previous hash.
The blockchain.
We
We have
have
our
a
block
block
number
number,
as usual.
we have a
And none.
nonce, which is trying to. All right, so the first block that we have, it is called Genesis block. It does not really have a previous hash because it doesn't have any previous hash, so it cannot be connected to any other block. So it is the first block of any blockchain, and it is called Genesis block. So that's all. So as we have our previous hash, nonce, and our block, and these all blocks are connected. As you can see, these all are connected with previous hash and have
0 is connected with the next block.
0, 0,
So
1 to F. And all these succeeding blocks are connected to each other. So you guys must be wondering, what if I changed the data of the second block? I want you guys to guess what will happen when I try to change the data of the second block. Just write it in the comment section. What will happen if when I change the data field of the second block? What will happen? It yes, it
turns
turns
red.
red.
Why
Why
does
does
it
it
turn
turn
red?
red? Suppose
Suppose
I
I type
type HI here, it turns red, and every succeeding block turns red. So what does this turns red means? It is not, the whole blockchain breaks out because for this particular digital data, the hash has changed, and the hash was connected to the next block, and that block has its different data, and now it has different data. So the whole blockchain has been broken because we have tempered with any. So
this
this
idea
was what
comes
comes
in
in
the
the
blockchain.
blockchain.
Imagine
Imagine
I'm
I'm
having
having tens of thousands of different blocks. So whenever I tries to change the previous data, the whole blockchain of that part breaks out. So There is where that is how the blockchains are connected and they are made secured. So you cannot really tamper with it. So you guys must be wondering what is this mine button I have here. So let us explore this mine button. I have this HI and when
Trying to identify
all the hashes which start with zero for that particular data. So let's just press mine button. What happens? It'll take a little bit of time. All right. So for the nonce value of 559,396, the hash starts with four zeros for that particular data, which is HI.
of mining in general, and we'll be looking at
At
the
what mining exactly is in our further slides as well. So we'll look at the block and how these blocks are really connected to each other. So this block is just in my local machine. It is just on my server. It is not going to make any transactions if I send money to anyone or anything. If I do, uh, it won't affect others as well. So there comes a concept of distributed. So what happens in a distributed ledger is we have
is all connected with the
hash,
hash
and previous hashes. So these all are connected in a chain. And what happens is a peer one, peer two, peer B, or peer C all have the same copy of all these datas. So these all have the same sort of data, the same transaction hashes that I have. So if I try to change my blockchain, the blockchain that is on my server, I try to change it. Suppose I try Mohit here, type my name, and I pressed
fake transaction. Suppose I did all
this
this.
fake transaction and I press that mine button, and now it is trying to identify the all the hashes, and now the block is green. So it is good to go, right? But what happens is, as you can see, the hash starts with 676 something, but on the other people's other nodes, what we call it in tech terms, on the other nodes is those hash won't be the same. And the
Another one is
it's
also
also
4B.
4B. So what the whole blockchain is trying to do is it is sort of trying to vote whether whether the transaction that I did is genuine or not. If I did a fake transaction, if I did something, if I tampered with my blockchain, if I tampered with any of the data, rest of the blockchain wouldn't accept my blockchain, and it would the transaction would get failed, of course. So this is what happens generally in our blockchain. All these blockchains and
The
specific
specific term for
is
this
what is
is happening in
voting
voting
system.
system.
It is called validation, and these are all connected to consensus mechanism, and we'll be looking at them in the next slide. So this is what is happening, and this is how it keeps all the systems secured. So imagine having, I just have three nodes here. Imagine having tens of thousands of lakhs of nodes, and those nodes are connected. Every single one of them have a copy of the node, and you cannot really tamper with any of them. Suppose if I try to tamper with my blockchain won't be accepted into uh, won't be accepted.
The chain.
So this is what is happening in a blockchain in general. So let us try let us move ahead and let us move ahead and try to understand how this whole process of a blockchain it is happening in our real world, how it is happening. So let us try to look at it. So the first step is the transaction is requested. So I press that send button, I press that send 100 rupees, send one Ethereum, send one Bitcoin button. And what happens is
broadcasted
to all. So
is like sort of
all
all
the
the
other
other
nodes
nodes,
know that I
right?
did a transaction and it is broadcasted to every single node. Then comes the part of validation. All those nodes that my data was, that my transaction was broadcasted, it validates whether I did a fair transaction or not. So uh, this is what consensus mechanism comes into play. We'll be soon looking at the consensus, what exactly consensus mechanism is. So imagine there is a person, it is not how it is happening. Imagine a person sitting on a computer who's validating all the nodes. Suppose a transaction comes into the blockchain, it is broadcasted, and a person gives a tick mark to it whether it's a fair transaction or not. If it is not a fair transaction, all all his transaction, all the transaction uh, doesn't go through the blockchain. If the
The transaction is
fair,
fair,
a
the
transaction
transaction
of 10
rupees
rupees, it
checks
checks
my
my
previous
previous transaction. I had 100 rupees in my bank account, which was on the blockchain. So now blockchain knows I had just 100 rupees. So I cannot really send 200 rupees to anyone. All right. So it just verifies the transaction that it was a genuine transaction. After the verification happens, the blockchain adds those set of transaction. It creates a block of all the transaction that was created in a certain period of time. Suppose in 10 seconds, there were 50 transactions that happened in that certain period of time. And all those transactions got verified and a new block is created. All those verified blocks get a, all these blocks are of verified type, as you can see, and the transactions get completed in the end. So this is a very, very quick process. It depends on the blockchain type, but in general, it's a really, really quick process. And the other person receives 100 rupees, 200 rupees maybe. So this is sort of how blockchain really works. So let us talk about consensus. So in the previous slide, I talked about validation, the process of validation, how these
as a
person,
there's
there's
not
not such
this person
person
sitting
to
to
validate
validate
the nodes, but there is an algorithm embedded into the blockchain network whenever it is uh, whenever it is created for the first time, and it has a consensus mechanism. Consensus. Let us look at the definition of what a consensus is. So, consensus mechanism is a method for validating the entries in a blockchain network. So there may be a different uh, validating processes for different blockchains, and we have a lot of different validating processes, but there are uh, two most used validating processes, and the first one is called proof of work validation, or proof of work consensus algorithm. So what happens is, as the name suggests, proof of work, the one who shows that he is a genuine person by showing that he did a work on a blockchain, gets the authority, gets to verify the transaction. And when he does the transaction, when he verifies the transaction, he receives a reward. So proof of work is what Bitcoin is generally worked on. Bitcoin works on proof of work consensus algorithm. So what is happening is, imagine you are a miner, imagine you are a validator. So in proof of work we called miner, and proof of stake we call it a validator. So imagine you are a miner, and you have to show that you did a work. So how would you really show that you did a work? In previous slide, we took a concept of nuns. So when I press that mine button, the algorithm tries to identify what what is the probability of starting a hash with a zero for that digital data that is presented. So it was just for one transaction. It was just for one data that we did. Imagine it having for thousands of different transactions. The thousands of different transactions comes to me, and it tries to identify their nonce values. So it is just an example. So it requires tremendous amount of energy to do that. So there was a fun fact that the amount of energy that is required to do mining, uh, it was equivalent to New Zealand's total power supply, the total power that was consumed in New Zealand for 1 year. So as you can see, it is highly power consuming. And uh, whenever the node gets validated, whenever you gets all the transaction and you shows that you did a work by proving that by finding out all the nonce values of all those transactions, which takes a lot of computational power. So it is not like everybody can do it. It requires a highly big computers to do that. You cannot do on your 4 GB RAM computer. It doesn't work like that. I had a lot of questions. A lot of people were asking me, can I mine Bitcoin on my 4 GB computer? So it doesn't really happen like that. You need some big computing power computers to do the proof of work or mining process. So when I gets the validate or when I gets the request and I show them that I did a work and it was genuine. So it was a genuine work. Of course, I did a work to all those prove all those nonce values. Then my block is created and it is attached to the blockchain. So as soon as I verify the transaction, the block is added to the blockchain, and I gets a reward for every single time I mine. I create a block. I'm getting rewarded as 12 bitcoins. I'm just talking about Bitcoin network in. I'm 12
12
bitcoins,
bitcoins.
and
And
that
that
is
is
what
what
people are fighting for these days. Like, uh, it has a drawback because a lot of companies, a lot of big tech companies, what are they trying to do is they sort of dominates because they have big computers, they have big servers, they have big computing powers. So they sort of dominates or sort of uh, because they have high computing power, so they are getting chance to mine a block and they are getting rewarded as Bitcoin. So it is sort of becoming like an unfair these days. So the next, so according after the lot of technical evolution, we came to a new set of algorithm that verifies a transaction. It doesn't uses any computational powers, as the name suggests. The second one is proof of stake. As the name suggests, it doesn't requires you to do work. It requires your stake. Suppose, so the best example of proof of stake algorithm that a network uses is Ethereum. Ethereum, I'm sure you guys must have heard the term Ethereum. So what exactly does is Ethereum is built on proof of stake consensus algorithm. It was a proof of work uh, before 15th of September, but after that they switched to proof of stake. So what is happening in proof of stake? Let us just try to understand that. Suppose you have 15 Ethereum with yourself, and what you do is you put a stake on it. You put it on the table, and then what the algorithm does is it randomly their chooses
chooses
one
one
person
person
to
to
validate
validate.
those nodes. So it is a pseudo random algorithm, sort of like, which randomly chooses a single person to validate a node from all the person who have their stake. So it is not a centralized. So it does not depend on a single person who owns a big computer to mine a block. It is a random algorithm. So it is not centralized. It is distributed to a lot of nodes, and it can be uh, it requires you it doesn't requires any heavy computers as such. So what happens is when you put a stake on it and the algorithm chooses you randomly, then the verification process begins, and your computer automatically, suppose the algorithm automatically decides you to do all the verification. You don't have to do every single transaction manually. It just chooses you as uh, a person, as a node, to do all to verify all the transaction. And when it is done, and it depends on the amount of stake that you have. The person who have highest stake, the person who bids higher, suppose the
Ethereum on it.
and
To
compare
compare
it to a
work and
person who has 100 ethers, he will be getting chance to verify the nodes. So as soon as you verify, you get rewarded. So there is a concept of transaction fees. Every single time you do a transaction, every single time you hit those send button, there is some transaction fees that goes to the validator. So it works like that. So the validator gets a reward by putting his stake. Suppose he did a unfair transaction. Suppose he had 100 ethers. He put a stake on it, and he tried to tamper with the block. He tried to tamper with the blockchain. So what will happen is the from that stake, the his part of Ethereum or will be deducted. So it is sort of like losing your ether from if you how works in general. So there are a lot of other consensus mechanism, but these are most used consensus mechanism in today's life. So after this, let us try to have a visual demonstration of what we have learned so far. So I'll go to this website. Uh, let us have a blockchain create. Let us create a blockchain. I'll create a blockchain. I'll start with, suppose my name is Mohit. Nice. I write any message. I say hi there. I put submit. So what I've done is I've created a Genesis block. I've created the first block, and you all guys can participate into this blockchain, and you guys can all become a node into it. So I'll just share this link, and you guys can come to this blockchain. I'll just put it in the chat section. So join this network. You have the link in the chat section. You have to just click on it and put your name, email ID, and just any message that you wish, and you can be part of this blockchain that we are running right now. So this is what I want to do, guys, right now. Just open your computer and try to participate in this. So we have three entries. So every four transaction creates one block. So as we have 12 entries, we can see we have 12 entries, and every four transaction creates one single block. As you can see, we have multiple nodes. So you guys all have the same data that I have. Whenever you guys typed any message, suppose I try to tamper with all you all have the same records that I have. Suppose I tried to tamper with it. I wrote a message, and I did some editing to it, and I requested a validation. Will be choose will be
we get a chance, we'll be getting a chance to
perform
validate.
validation. Suppose I got a validation request. I perform a validation, and it went through because that was a genuine transaction. But I did a fake transaction. I tampered with the blockchain, and then I request a validation. And as you can see, it is failed. And the line, there is a red line that you can see that that I've tampered with my block, and it doesn't went through the blockchain. So just try to tamper with it and put a request validation. We have 44 entries right now. So we have 44 total participants in the blockchain. The more participants that we have in a blockchain, the more secure it is, because it is a voting process sort of like. So Devansh tried to tamper with his block. It didn't went through. So you guys must be receiving those validation requests. So that is what algorithm is trying to do. It is trying to randomly, it is not stake, you don't have any ether right now. So it is randomly selecting a person who is chosen to validate those transactions, while you validate all the blockchain. Awesome guys, awesome. We have 50 total participants. So there was a unfair transaction again. It didn't went through. So this is exactly what is happening when in our daily blockchain in just uh, so again Monish tried to tamper with his block. It didn't went through. All right, guys. So this is what is happening in blockchain, and let us let us move ahead. We can play this all day long. So the network that I'm using right now, it's called Gazillion network. You guys can participate in it as well. And let's just move ahead. Right? So we talked about consensus. It is a validation process that the blockchain has. So this is one of my favorite quotes till now. So blockchain is a technological breakthrough that will change the world in ways you can't even imagine today. And I, I highly agree with this because it is a revolutionary technology according to me. So let us look at the different use
uh,
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 of
blockchain
technology.
technology.
There
There
are
are
various
various
different applications of blockchain technology. It is not just limited to doing transactions or just sending money to anyone. It can be used in various different fields. Suppose financial transaction is what we saw right now. It's a trivial thing that we know. Then comes healthcare sector. So the data field that we talked about in our visual demonstration, those data field can be of various different types. If I add an image to that data type, it is sort of called an NFT. We'll be covering that topic. Piyush will be covering that topic. So that is called NFT, and we can play with these things a lot. Like suppose there we can create a decentralized or universal ledger for all those I'm talking about healthcare, all those patients record, and we can put them on blockchain. Suppose I in X city, and all the records that were generated during that time, that can be put on blockchain. And whenever even if I went to any different country, that doctor can access through my records because it is just on a universal, it is just on one big ledger, and all these files, all these transactions, all these healthcare records are just on one thing, and you can access, anyone can access, and not exactly anyone, you need authority for that, but there can be access, and you don't need any central servers to do that. And it is a highly efficient and energy saving process. You don't need any servers to maintain. There requires a lot of money to maintain servers. There's a big application of supply chain also. Supply chain has a big role. It's playing a big role in our daily world. All those shipping and all, it happens on a different centralized servers, and somewhere someone might tamper with those records. Suppose I have a Nike shoes, and there's no proof that it is made from Nike store. But if you include a supply chain, if you include blockchain to the supply chain, you can track all.
Really it is tamper proof.
So supply chain has a big application of blockchain, and there are voting systems and identification. So these all are still research in a research phase, and we haven't uh, explored much of these technologies yet. But this is what future is going to be look like. The technology is ripening yet. It will take time, but the next decade is going to be about this also. This only. All right, guys. So I'll ask Piyush to take it on from here. We'll have some amazing topics to cover. So I'll ask Piyush to take it on from here.
So, hey guys, and thanks Mohit for this wonderful explanation. So, now I'll be taking over. I'm Piyush Karma, your blockchain colleague. So, let me share my screen. So, okay, let's start with smart contracts. So, what are smart contracts? These are the building blocks of blockchain. So, a technical definition of smart contract would sound like smart contracts are digital contracts stored on a blockchain that are automatically executed when a predetermined conditions are met. So, this is a very technical definition of what a smart contract is. So, now let's try to understand what it in simple terms. This is a very typical traditional example. Suppose there are two users, user 1 and user 2. User 1 wants to deposit his or her money to the bank. Now user 2 wants to withdraw that, or maybe that person wants to take a loan from the bank. But for this case, they have to have a mediator in between, and that mediator role is played by banks. But in contrast to that, when we use blockchain technology and we use smart contract, we have automated this process. We use computer codes, which are smart contracts that are deployed on blockchain to perform these transactions. As you can see in the second case, where there is a smart contract, user 1 and user 2 can automatically do this transaction. No mediator is required in between. So smart contract simply plays a role of a mediator in most cases. So now let's take a more real life example. Suppose there are two persons, one is Bob and one is John. Bob wants to sell his property and John wants to buy a property. Now suppose Bob agrees to sell his property to John, and John agrees to buy that property from Bob. So in a real life case, there may be like many kinds of disputes that may happen. But smart contracts comes into play. It can automate the process and create a trust in transaction. So let's take a look how it happens. So suppose, how do you prove that you have the ownership of that asset or that property? You have legal you have legal documents to prove that yes, you are the owner. Now suppose, for example, let's suppose smart contract has that ability to create those kind of documents. So what it will do, it will take money or cryptocurrencies from John, which will be like equivalent to the amount Bob would want for his property. So when the John pays for the property, the cryptocurrency or money will be transferred to Bob, and a ownership document will be created for John. So in this case, all the process will be automated, and there won't be any case of scams or frauds. Okay, so we have talked about what smart contract does. So now let's talk how it is created. So in reality, there are various ways of creating smart contract. It literally depends on the blockchain you are working with, you have selected. So each blockchain has their own architecture. As Mohit discussed, they have different consensus method and different architecture. So it totally depends on them, what technology stack they use to make their smart contracts. Generally, Solidity, Rust, and C are used. Why we are focusing on it? Because like generally, blockchain is a very new topic. So if you are starting to learn it, I would prefer you should start with Solidity, then Rust and C. because if you are going to face you definitely are going to face some problems while developing it. So Solidity, Rust, and these all have large communities online from which you can seek guidance and help. Okay, so like the choice of tech stack for making smart contracts totally depends upon your choice of blockchain. So it will be more clear when we move further. So this is a very simple example of a smart contract. This is created from Solidity. Solidity is not kind of an alien language or something. It follows the simple OOPS structure, object-oriented programming. Just it is that it is called contract-oriented, and it has the similar syntax to C++, Python, and JavaScript. So nothing new in that. So if you can see, this smart contract is deployable on the blockchain, and what it does is simply it stores a value, and then we can return, we can extract the value. We have function set, function get, as we have in any other programming language. Okay, so now let's discuss cryptocurrencies and blockchain and how smart contracts plays a role in them. Okay, so what are cryptocurrencies? Cryptocurrency is a medium of exchange such as Indian rupee, but is digital and uses cryptographic techniques and its protocol to verify the transfer of funds and control the creation of monetary units. Very technical definition. So how does it work? So it uses it actually takes the advantage of existing blockchain technology because it works on blockchain. It works exactly same like how Mohit explained. The transactions work on blockchain. A new transaction is created. It is first verified. Then a transaction block is created, and then it is added to the existing blockchain, and that is immutable. So it provides much better trustful way of making payments instead of the uh, already existing payment technology, because it uses the existing blockchain technology. So how do you make cryptocurrencies? To understand that, you need to understand concept of tokens. So tokens are created using smart contracts, which we just discussed. So you create a smart contract and deploy it on which you create a smart contract which is used to make tokens. Then you deploy it on a blockchain network. So that way you create tokens. And there are few standards, like few typical ways of creating tokens, namely ERC20, ERC721, ERC777, like etc. So why do we require these standards? So now let's take an example, user mind. Okay, suppose you are going to some shop, your local shop. You are buying something, 19 rupees, 19, but you only have 20 rupees note. So what will shopkeeper do? That person won't return you 1 rupees, but instead that person will give you a toffee worth 1 rupee, right? It generally happens. So now you have in return a toffee which is worth 1 rupees. Suppose you go next day to the same shop. Okay, then you can redeem that 1 rupee toffee as 1 rupee. If you are going there to buy something and you are short of 1 rupee, so instead of 1 rupee coin, you can give him that toffee. Okay, so that is how tokens work. They gain monetary value according to the situations and market conditions. Now, why do they need standards? Suppose I take that same toffee and take that toffee to another shopkeeper. What if that shopkeeper doesn't know its value? Like that person doesn't know what that toffee is worth. Like, is it worth 1 rupee, 2 rupee, 10 rupee, or like that toffee is expired or something? So they need to have a mechanism that tokens need to have some standards, so that it can be exchanged with each other, and like it is compatible with different systems. So that's why we follow standards in tokens. So while all tokens are cryptocurrencies, not all cryptocurrencies are tokens. Okay. And token here can represent anything. It may be cryptocurrency. It may be a concept of, like, suppose I create a picture and tokenize it. That is what we call NFT. And for creating NFTs, you need to know concept of tokens, and tokens are made using smart contracts. Simple. So you may be confused. There are so many blockchains, so many cryptocurrencies. You might be like, just be puzzled about it. Like, why is this? So theoretically, blockchains can be classified into four groups: public, private, hybrid, consortium. Okay, but in to understand it in a simple terms, you can classify it as Ethereum, which uses EVM technology. I'll discuss it later. What is EVM? Then blockchains which are based on EVM, and there is Solana, which is a big blockchain, and the other blockchains. Okay, so broadly classified it like this. Okay, here are a few examples which you might be familiar with. So first one is Ethereum itself, EVM based blockchain. So first is Binance Smart Chain, Polygon. Polygon is an EVM based blockchain. Then there is a standalone Solana. Others may be Bitcoin and Tron. They don't use EVMs. So we were talking about EVMs, EVM. So what is EVM? EVM is simply like a compiler or a virtual environment which allows creation and execution of smart contract. So that like you created a code, you need a compiler for it, for that to run, compiler or interpreter. Okay, you need that thing to run your code. So EVM is just like that. When you create a code in Solidity, it needs EVM to run. And as we just discussed, there are like Solidity needs EVM, and EVM is present in Ethereum, Binance Smart Chain, Polygon.
These things are capable of
Using Solidity for creating their smart contracts. So in short, you can use the same Solidity smart contract in all these blockchains. Now, understand, same smart contract can be used in all these blockchains. Smart contract is used to create that token. So in short, that means can exist in all these blockchains. Which so suppose you create a token for a blockchain which is EVM compatible. So then you can deploy that token on all the blockchains. Those are EVM compatible. So what is the future in blockchain? Now let's see. Scope of blockchain. So since the blockchain has come into like eyes of people since 2017, it was introduced through cryptocurrencies among people. Since then, it has only grown, only expanded. It has shown immense potential. It has shown like breakthrough track. It was a breakthrough technology during that time. It has shown like a different alternative or better approach of doing the same things which we did earlier, using like some old technology uh, like suppose banking, health, security, payments. We all used to do, although we still do, but we now have alternate mediums too. Like blockchain has revolutionized payments and it is going to expand. Blockchain has actually acted as a catalyst for performing things. It has acted as a better alternative to the existing framework. That is why blockchain is still growing. Although although it is this much complex, but still people are demanding it because it has the potential to take over all the existing technologies which we have right now. So let's see some statistics. Okay, so worldwide spending on blockchain solutions 2021, $6 billion. Distribution of blockchain market value. Banking is using blockchain. Largest blockchain use case: cross-border payments, settlements. Now just think of a scenario where you have some like you have to purchase something in some foreign country. So what you'll do? Suppose I want to purchase some property in US. So I'll contact a mediator, broker, more specifically, that yeah, I want to this kind of property, I want this kind of things and XYZ. Then I have to trust on that person, like yeah, I am sending this money, then that person will surely provide me the ownership. I'll have to depend on that person. Like I have to devote my trust on that person, even though I am not sure about it. But just consider the case of blockchain. Now you don't have to apply that much thought process to it. You know that this thing's gonna work. You know for sure if you have paid, you will get the ownership. Now, uh, global blockchain technology market share. Financial services has the highest share in blockchain technology usage, and even government is using blockchain technology. Blockchain technology market size. See where it has started in 2018 and where it is supposed predicted to go by 2030. Demand growth for engineering roles. Blockchain has shown 500% plus growth rate. Why? So, as I just explained, there is this older technology which we used after blockchain has been introduced. Now people want to change like existing infrastructure to blockchain. So we have this much old technology which we already use. Now that needs to be changed. So we need blockchain developers for that. And after introduction of blockchain, we have new things to create, new ways of doing things, new like technologies, new things which we can build on blockchain which we couldn't have earlier. So that is also needs to build. So we have this whole spectrum of things which needs to be done by blockchain developers. So that's why there is a huge demand for blockchain engineers. So it's like this much big demand and supply is only limited. So let's compare salaries. So you can see the average salary, and it is obvious when we have a high supply and a low demand. Sorry, high demand and a low supply, then obviously that things gonna get costlier. So you can see blockchain developers have generally higher annual average salaries. So what are you supposed to do as a blockchain developer? You might be curious if you want to pursue it. So there are mainly four roles, like core blockchain development, smart contract developer, or a security analyst of that smart contract, and some other front end related things and some other integration things which are also there. So core blockchain developer means someone created Ethereum, someone created Polygon, and now, for example, someone created a voting system, a blockchain based voting system. Suppose I created a blockchain based voting system and I deployed that on Ethereum or Polygon. So then I'm a smart contract developer. I am not a core blockchain developer. So there is one core developer and there is one who uses that blockchain technology to provide services using smart contracts. And there is one who hacks or analyzes its security. So so for core blockchain development, you need very in-depth knowledge of blockchain as you are going to build one, obviously, and some programming languages like JavaScript, Python, Go, Golang, etc., etc. Knowledge of oracles, smart contracts, obviously. You need to know scaling and DevOps, and much more things. And what you need to be a smart contract developer. Why I would prefer you to choose this path is like even though many blockchains are being developed, but still they have a limited scope. Mostly, what you need to like there are already existing good enough blockchains. So it isn't like you will just come with another search engine to try to beat Google. Okay, you have powerful search engines. So like trying to create another one like that, I don't think so that's much of an wise decision to make as a career choice. Okay, so you can like learn that to apply to Google and uh, come okay, contribute there in its development and maintenance. But what you can also do is like using that existing technology and creating new services with it, which has like immense potential and opportunities. So how you can be one? Be a smart contract or dApp developer. You need to have some general knowledge of blockchain. You should know a few programming languages like JavaScript, Python, Solidity, Munstack, Django full stack, and there are few frameworks which we use for Web3 development, Truffle. hard at, Web3.js, Ether.js, Ganache, which is our testnet, which we use while developing, and obviously DevOps. Okay, so now you must be having a lots of doubts regarding blockchain technology and how to be a dApp developer. Okay, to ask, bombard us with all of your questions. That was all from our side.
All right, guys, if you have any questions, you can put it in the question section, Q&A section, and we'll be happy to answer them.
Keep asking, guys. We are waiting. We are here only to answer your queries. Is this part of cybersecurity? I am from cybersecurity, so I want to see. Blockchain provides security, and there are like scope for smart contract security analyst. Because although we say like things are immutable on blockchain and things like that, but we still have some loopholes in the codes we create, so they can still be hacked. Smart contracts can still be hacked. So as a cybersecurity, if you want to pursue cybersecurity, blockchain security or smart contract security can be one of your career options.
So Pratap asked, can you remove a block from a network? So no, you cannot really remove any blocks.
In the blockchain, you cannot remove any blocks.
You can do updates in further mode, adding more block. You can do more transactions, but no, you cannot remove.
Like you may take courses, but what I as a developer feel like you can start with development and go with the theory side by side, because to be a complete blockchain developer you need to know your theory. Okay, and then to like properly understand the theory you need to know development. So I think that should go hand in hand. Okay, so what should be the roadmap for first year CSE student who wants to learn? So if I may, so you can take a screenshot of this, how to be a dApp developer. Okay, and you can like simply learn all the technologies mentioned here.
So Prashant asked, can you suggest us best source to learn about blockchain technology, free cost and best material? All right, so Prashant, there is a YouTube channel called freecodecamp.org. So it has a 31 hour session, a 31-hour video of how to become a blockchain developer and all about blockchain development. So you can take that. It is free. It is on YouTube. So that is what I will suggest.
See, Prashant, as I can see you are from first year, so I would suggest you to first try with learning more programming languages. Be like try to master it, and then learn web development as well as blockchain. Okay, so then you can like create some meaningful things after you have learned to create smart contracts. And yeah, obviously we'll be having one session on that too. Okay. Uh, Okay, so you want to know why do you like trust Bitcoin? See, simply, blockchain is all about getting the trust. Okay, it is not just one person governing the whole system. I may be a total fraud, I may be a total criminal, but I like followed the principles of how to create a blockchain, and I created it. So if you know what mechanism it uses, like the consensus mechanism with Mohit discussed. So if you know that, you know how your things are going to get validated, and you know the level of security blockchain follows. Like you can't just manipulate any data on your own wish, or like you can't just simply change the rules out of nowhere. There is no one single central authority that is controlling the blockchain. So that's why you trust Bitcoin, because it is on blockchain. See, cloud specialization. See, for cloud, I would say first you need to learn web development. You need to know how like things, programs are architectured, how database and everything is connected, what role cloud plays in it. In reality, it doesn't simply mean you are from cloud, so you will only do cloud and everything. So, although blockchain is there to provide everything what you want, but we still need the existing infrastructure to work with it. We still need websites, we still need front end, we still need database and everything for like smooth, making the app much more successful and much more user friendly. Okay, so we still need the existing technology, and yeah, cloud is one of those technologies.
So Atharva asked, can you please suggest any books that we can read to? I wouldn't suggest any books as such for now. You don't need books to learn blockchain technology. There is a lot of material available online on YouTube. I would recommend you to have that. Books are not necessary for now.
So, what are the job opportunities in blockchain? So, I just discussed there are typically like four types, you can say, of. Let me show you the slide. The core development, like the person who developed Ethereum, like Ethereum blockchain or the Polygon blockchain, had a different set of knowledge. And then, without going into that much depth of blockchain, you can still be a blockchain developer, or you can say a dApp developer. DAPP. That means decentralized application developer. Applications which uses blockchain technology to provide services, like maybe voting system, maybe creating a banking system out of that blockchain technology. Like you can create immense, yeah, numerous applications on blockchain. Okay, so you need to know that kind of development skills for that.
So Pratap asked, why it takes huge power source to mint Bitcoin? So as is discussed, it works on the consensus mechanism called proof of work. So the more you give them proof that you are working, the more you get a chance of validating a node. And if you validate a transaction, you get a Bitcoin. So that is why it works on proof of work. So you have to show that you did a lot of work.
Okay, guys, keep bombarding. We are waiting for your questions. Ask as much as you want.
Blockchain is a total different side of investing, cryptocurrencies, and total those side. We haven't discussed any of that in our session. Uh, it was a total different session from that. Okay, so if you guys expected that we'll be talking about some trading or investments about in cryptocurrency, it wasn't. It wasn't that session.
We were much more inclined on making you guys familiar with blockchain technology and how things evolve around it, and how you can become one blockchain developer.
So for those who are in 2022 batch, I wouldn't recommend to just take this technology as a career opportunity for now. Just keep exploring, explore as much as you can, learn what is required, learn web development, app development, whatever other things are required. But just keep exploring this technology parallelly, and that is how you will learn about it. Just don't try to solely learn this technology.
Like, don't straightfully jump into blockchain like after you have seen this session. You need to know web development at least, or app development, some kind of development to link blockchain with. easiest it would be to start with web development, and if you are enthusiastic enough, you can start with app development. Guys, questions, keep asking.
There was a question from which source should we follow the theory only? So for just learning about the theory, there's a wonderful channel called Whiteboard Crypto. It is on YouTube. So it just gives you general knowledge on uh, blockchain, NFTs, a consensus mechanism, and blockchain in general. So you can follow that channel. It's an amazing channel. Thank you, Akash.
Uh, Angira Tiwari, roadmap for being an app developer is totally different. I assume you are from first year, right? So there are different roadmaps to be different developers. And my journey was like I basically kept on jumping from one development to another. So I have like quite some idea of like most of the development stacks. So what I would say, start with you can start with Flutter, or I think I would say there are much more appropriate people than me. You can contact Harshraj, who is the blockchain Android colleague of GDSC. He'll guide you, and you can also contact Apurva for that. For blockchain, uh, you want to be a blockchain developer. Okay, same goes for you. Take a screenshot of this. Learn all these technologies step by step.
For those of you guys are waiting, we'll be having a session of a workshop, 3-day workshop regarding blockchain. So we'll be having it soon. We'll notify you.
We will have a total development session on blockchain, like as Mark mentioned, for smart contract creation very soon. We are planning on it, working on it. Okay, guys, more questions. Welcome, Angira. Okay, and don't forget to fill out the attendance form for the certificates. If you know about gas optimization and energy consumption, that is one of the like, most common challenges faced by blockchain technology. And yes, it is totally a little complex. That's why it has little lack of people that go into blockchain technology. And those who are smart enough can encash this opportunity to be a blockchain developer and earn like bigger amounts.
So Chinta asked how blockchain made from JS, Python, or Solidity are different from each other. So blockchain is a linked list. So those of you who have studied data structures and algorithm, blockchain is a linked list. So you can create linked list in any languages. It won't matter. So there's no much difference in creating which technology you choose to create a smart contract, blockchain. creating a blockchain is not a big part. You can really create it in like 10 minutes, but scaling it and it is what the difficult part is.
So, like, why do we like have different languages? Which actually I covered that part. I will repeat it again. We have different blockchains. Different blockchains have different, what you can say, compilers of blockchain. Although that's not the appropriate word for it, but in simple terms, you can say different blockchains have different compilers of their smart contract. Different compilers work for different languages. Most commonly used, EVM compiles Solidity. Solana is a blockchain which has its own compiler which uses Rust and C. Okay. And they are not different, they use just different languages to create them. There are much more than that. For being a security analyst, you need to have good knowledge of smart contracts and like proper knowledge of smart contracts and loopholes in them. They not just use Kali Linux, they have various different technologies to use. Okay. And there are various like in cyber security only there are various domains which you can cover: app security, as like application security, web security, and I guess there are like, blockchain obviously, and there are many others. So this is one of the domain you could explore if you want. Can you just show me how are NFTs and blockchains connected? Okay, so if you remember I talked about tokens. Okay, so tokens are created from smart contracts. Tokens are created from smart contracts, and smart contracts are deployed on blockchain. And token can be anything. I can simply like have my headphone being tokenized. I can like literally tokenize anything digitally. Okay, so NFTs contain an image which is tokenized. You provide you like then image has a ownership, like it has one owner. So that's how NFT works. Yeah, definitely. We have layer 2, which has promised to reduce the transaction times and gas fees. Okay, so technology is continuously evolving. You need to keep up with it. Shashwat. Okay. Okay, guys. Thanks. Thank you. We'll be ending it now. And you have our socials. I guess Aishman can resend it. If you still have doubts, you can contact us through them. Okay. Have a nice day.
All right, guys. Thank you very much for attending this session.
Thank you so much.